Hello and welcome to Slooh.com. My name is Will Gator and you join us here on a special show as part of Slooh's Comet Week. A special welcome to those of you joining us from Slooh's 24-hour live channel. Now, normally we'd be bringing you live views from Slooh's Canary Islands observatories, but unfortunately we've had a bit of humidity there up on the mountain and up at the observatory site. So instead we're looking at a very interesting comet. Now, earlier in the week, we had a fantastic live show looking at another comet, Comet Catalina, which is really putting on a great show in the pre-dawn sky, and in fact is becoming more and more visible to those of us in sort of mid-latitudes here in Europe and the UK and even North America. But the comet we want to talk about this evening is 67P, Churyumov-Gerasimenko, the comet that European Space Agency's Rosetta probe has visited and is visiting as we speak, currently orbiting the comet and sending back fantastic pictures like the one you can see on your screen right now. 67P, really, we've learned so much about it in the last year, and that's what we're going to be talking about with some of the scientists who've actually been studying the images, studying the data coming down from Rosetta, and that's what we're going to be talking about in this show. The comet itself, well, the views that you're seeing on there are really quite extraordinary. The comet is a few kilometers wide. It has actually two lobes. You can see in the spectacular images we were showing just before, these two sort of main bodies, and there's a lot of discussion, in fact, how that formed and how that actual two-lobed feature formed. But we're going to be touching on some of the other subjects, things like how has the comet changed? Because one of the amazing things that Rosetta has done is it's allowed us to study the comet as it evolves. Rosetta arrived at the comet last year, and in that time the comet has come into the inner solar system, come closer to the warmth of the sun, and the gases and ices have been released from the surface and underneath the surface of the comet and have caused all sorts of fascinating activity. And that's something that we're going to be talking about with some of the scientists who've actually worked on the mission. Now, we last checked in with the Rosetta team and the Rosetta mission around about the time of Perihelion, when the comet was making that close approach, or its closest approach in its orbit to the sun. And we spoke to Matt Taylor, and he told us about some of the incredible things that the comet had found up to the space probe had found up to that point. But to talk a little bit about how things have developed since then, I'd like to bring in our first guest, and that is Jean-Baptiste Vincent from the Max Planck Institute for Solar System Research. And he joined us now on the line. Jean-Baptiste, thank you for coming on to Slooh this evening and talking to us about this really fascinating comet. I know you've worked with the OSIRIS camera on the mission, but what are the sort of things that we've learnt since Perihelion, even over the last couple of months? What have been the things that have really caught your eye at this comet?
Hi, Will, and thanks for having me on the show. So what have we learned? Well, in the last months, especially after Perihelion, we have seen that the activity of the comet has increased a lot. We actually reached the maximum of activity about a little bit than a month after Perihelion. And at that time, we have seen many outbursts, which are this sudden release of gas and dust, these very explosive events where suddenly the comets eject a chunk of ice and dust that is as bright as the nucleus in our images, while usually like, I don't know, your viewers I think, can see one of the images of the comet now on the screen, and you have all these small jets around the comet that are usually not very bright, but these outbursts were several orders of magnitude brighter than the typical jets. So this is one of the very interesting things that we have seen after perihelion.
I know your specialist interest is in fact the jets and the sort of activity that we can see on screen right now, and this fantastic image of an outburst there on one of the cometary lobes. Was it how you imagined? Is it different? I mean, have things surprised you over the last few months?
Yes, we were expecting to see a few outbursts, but some of them have been really strange. So we have seen a few of them from the night side where we were not expecting to see any activity, for instance, but suddenly there was this massive release of gas and dust, and we have seen others that seem to repeat from the same place several times in a row. So in the same day, we can see 2 or 3 outbursts from the same place, and then suddenly nothing for several days, and then it starts again. And we are trying to monitor all these things and to try to understand why they happen from a specific place on the comet and not from another one, and what does it tell us about the comet itself.
For our viewers watching who perhaps don't know how a sort of comet works, what is it that's actually causing these plumes, these outbursts, we think? What's the process at work there?
So you have so the comet is made of ice and dust mainly, and the ice is sublimating because the temperature is high enough to have the ice transform into gas directly, and this gas escapes into the vacuum and accelerates the dust grains that are on the surface. And normally this is a gentle process, and the grains, the dust that is accelerated away from the comet escapes very gently, just a few meters per second. So it's just above the escape velocity. So it can escape the gravitational attraction of the comet. But these outbursts, they are much, much faster. So somehow, in these regions that are outbursting, the comet is able to build up some pressure under the surface until you reach a point where everything explodes, and basically you have a large amount of dust that can be ejected.
And presumably this sort of thing can tell us about the structure, maybe the strength of the comet surface. Would that be fair to say?
Oh yes, yes, absolutely. And we are looking
One of the
into
things
that.
One of the things that you've looked at with the Osiris camera is those amazing pits, those sort of great holes in the comet. What do we think they are?
So these holes, for most of them, we think they are the result of a collapse of the surface. Yeah, you have one on the screen right now, one of the most impressive actually. It's about 200 meters diameter and 200 meters depth. And we
Wow.
believe that it's the collapse of the surface on an underlying cavity. And this cavity may have been formed by various processes. It may be original, it may be there since the formation of the comet, or it can be due to the sublimation of ice that was trapped deep below the surface. And at some point, you create a hole under the surface that is too large for the surface to be able to support its own weight, and everything collapses into the hole. And this may be accompanied by an outburst at the same time. So we don't know for sure. That's why we are now very eager to get back close to the nucleus with the spacecraft and be able to look in details at these regions that have been outbursting in the last couple of months.
Well, of course, we've passed perihelion now. The comet and Rosetta with it is traveling back out into the solar system. What's the future for the mission and for the spacecraft?
Okay, so in the last few months, we were quite far away from the comet because it was too active and we couldn't get close to the nucleus, basically. We couldn't navigate with the spacecraft around the comet. Today, we are at 99 kilometers, so we are finally below 100 kilometers from the surface and getting closer. So in the coming months, we will get closer and closer until we reach 30 kilometers or even less. And we will look first at the southern hemisphere in great details to see what's the structure there, because it's the most active hemisphere of the comet, And so far, we have not been able to really observe it from a close distance. After that,
Certainly.
yes, tell me.
No, so you're getting an incredibly close look, it sounds like, over the coming months.
Yes, yes, yes. This will happen at the end of January and in February 2016. After that, we will continue to follow the comet. There are many discussions now in the Rosetta team about the kind of trajectories we want to have, and if we want to stay close all the time, or if we want to have an excursion in the tail of the comet, for instance, for a few weeks, and we are discussing this. And we will continue like this, so to follow the comet, to observe what's happening on the surface, to look at the changes before and after perihelion, because we will be able to observe again the northern hemisphere in a few months and see if some things have changed with respect to what we had seen last year. And the mission is ending, so the nominal end of the mission will be June, July. That's the end of the real scientific part of the mission. And after that, we will slowly go down until we land the spacecraft on the comet. And this will happen at the end of September next year.
You mentioned you're getting a closer look and a closer orbit towards the comet, and a lot of people I know are fascinated by the story of the Philae lander, which, of course, the Rosetta spacecraft sent down to the surface of the comet, and it sort of bounced across the surface. And we're not entirely sure, or at least we don't exactly know exactly where it is on the comet. We have an area, don't we? We've actually got a Twitter question that relates to this from Peter Adams on Twitter, and he says, "Are there any recent updates on the attempts to contact the Philae lander?" I wonder if maybe your observations with Osiris, could they perhaps find it?
Yes, so we believe we know where the lander is with an uncertainty of a few tens of meters. For the last few months, we were too far from the comet to really see the lander, so we don't know better than that. But very soon we will get close again, and we'll be able to see the lander for sure, and see where is its final position. Now, about the contact with the lander, as you know, we had some contact in July this year, and we believe the lander is awake since April, actually. But the contact we had in the summer was not very good, so it was always very short, too short to actually be able to do science with the lander. And we didn't have any more contact after the summer because we were too far from the comet. So now the engineers working with the lander, they believe Philae is still alive and can communicate with us and can operate for at least till the end of January, let's say. So now we are trying everything we can as we go closer to communicate again with the lander, but so far with no luck.
Well, we'll keep our fingers crossed that Philae gets back in touch. It'd be so exciting if we could get just a
Oh
few more
yes,
images, maybe some data. Thank you, Jean-Baptiste, for coming on to speak to us here at Slooh. Thank you so much,
welcome.
and good luck over the next coming weeks and months. And I'm sure we'll hear back from you again, and we'll find out what you found come that point when you're getting really close to the comet. So thanks very
Yes,
much for coming on.
thanks, bye.
Well, we're going to take a short commercial break now, but when we come back, I'm going to be speaking to Colin Snodgrass from the Open University about how amateurs have played an important role in understanding this really enigmatic and fascinating comet. So come back in 30 seconds and we'll see you then. Well, welcome back to our special Comet show here as part of Comet Week on Slooh.com. We're looking at a specific comet tonight, Comet 67P Churyumov-Gerasimenko, the target for the European Space Agency's Rosetta mission. And we've got lots of programming coming up this week. And I just want to tell you very briefly about something that's coming up on Sunday night, because it's kind of tangentially related to comets, or at least small bodies of the solar system, because we're going to be observing the Geminid meteor shower, a beautiful meteor shower, perhaps arguably the best one of the year. A huge number of meteors generally seen if you can stay out for hours and wrap up warm. Wonderful meteor shower. And we've got special live coverage as part of that on our Comet Week. So that's on December the 13th at 8 p.m. Eastern Time and 5 p.m. Pacific Time. So don't miss that. We're going to have live images, and we'll have radio meteor detection and lots of commentary and music to keep you occupied and keep company if you're out observing, watching those meteors. So don't miss that show. For now, though, I want to bring in our next guest, who is Colin Snodgrass from the Open University. And Colin has been the coordinator of the ground-based campaign to study Comet Churyumov-Gerasimenko 67P. And it's really quite an important thing to do, to observe the comet from the ground. Would you say, Colin?
Hi, good evening. Yes, it's an important thing to look at the comet from the ground, because you get a much different scale. The important thing to remember about the Rosetta mission is that it's designed to look at the very heart of the comet, the nucleus. As Jean-Baptiste was saying, when the Rosetta is now about 100 kilometers from the nucleus, even when it's at its furthest, even when it goes on some large excursion, that's maybe only 1,000 kilometers away from the nucleus. When they talk about going into the tail, they talk about 1,000 kilometers. If you look at the images of the comet that's taken from the ground with the Slooh telescopes, for example, or with any of the telescopes we've been using in a worldwide campaign, you're seeing now a tail which stretches for hundreds of thousands of kilometers. So the scale of the total comet is much larger than just the sort of region that Rosetta can explore. So this is why the ground-based campaign that supports the mission is so important, to give this context to understand the larger scale comet.
And the tail that we're seeing, what is it made of in these images? Traditionally, we think of multiple tails of comets. Sometimes comets have very short or very wavy tails. What is it we're actually seeing of this comet?
So most of what we see in the comet here is we're seeing dust. So what we're seeing is the reflected sunlight coming back from the solid grains that are being released from the comet. In bright comets, we traditionally think of two main sorts of tail: the dust tail, which is this reflected light, and also the ion tail, which is glowing ions, and those travel straight away from the sun, whereas the dust tails seem to have a more curved path. In the case of Churyumov-Gerasimenko, this is long, thin trail we're seeing here is mostly dust, however, because it's not so bright that we can really detect the ions very easily.
What sort of parts of the comet, in terms of what sort of discoveries can you actually make by looking at this wide view? Or is it more about linking into what Rosetta's seeing?
So the key thing is to link into Rosetta, because of course Rosetta will only ever go and visit this one comet, and as much as we'd like to, we won't convince the space agencies to send one of these spacecraft to every comet we'd like to study. So the point of having these sort of parallel observations means that we can compare these with similar observations of other comets and look for similarities and common features that we can then attribute to certain features or certain measurements that Rosetta's making at the moment.
And of course, part of this ground-based observing campaign is not only sort of professional telescopes, but amateurs too. How have you been working with them and coordinating with them to get their data?
So there is a large amateur campaign, and this is it's quite a key part of this, because the comet, especially in the last few months or so since Perihelion in August, has been quite difficult to observe. It's relatively close to the sun and only visible for a short period of time in the evening sky. So now it's observable for maybe a few hours at the end of the night. But especially early on, you could only see it from any given telescope for maybe half an hour to an hour. And while we've got a lot of professional telescopes following this, there are only so many in the world, and they're only in so many places, whereas amateurs have a much wider range. There are many more places. So it also means that if it's cloudy in one place, the chances are someone can observe it from somewhere else. And as well, because we have things like Slooh, where you have really professional grade telescopes that are available to amateurs, they've been able to take these wonderful images that are really, as they contribute as much as some of the professional images we've been taking. So the way that the amateurs observing the comet can contribute directly to the mission is that there is a site, an FTP server set up at ESA that allows amateurs to submit their data directly to there. And so this site is to collect data from amateurs all around the world. You can sign up for an account on this server, and then we can collect the data directly, and then it can feed into the whole campaign.
Fantastic, and we're seeing some pictures here, and presumably this allows you to track the changes of the comet, the appearance and events that might be going on the surface, and relate them to what Rosetta's seeing.
Yes, well, I mean, one of the things that is difficult for Rosetta to do is to judge what's the sort of total activity of the comet. I've described it before as the Rosetta has a trouble seeing the wood for the trees. It's really so close into the center that you don't see the total activity of the comet as much. Whereas when you see the comet from outside, you can measure every night how bright is it, and look and see how does this change over long periods. Some of these outbursts, for example, that were mentioned before, John Baptiste was showing, these are very short events, and it's relatively easy for these to be missed by Rosetta if it just happens that they weren't taking images at those times because they're so short. Whereas anything that's a larger outburst that affects the total brightness of the whole comet, you'll see from the ground because it will take some days for the brightness to peak and then drop again.
Well, it's fascinating. Hopefully, some of our Slooh members will continue sending in observations and image data from our cameras and our telescopes. We're going to be speaking to one of them very shortly. But Colin, thank you so much for coming on here to Slooh and talking to us about the ground observing campaign. And I hope we'll catch up with you again soon.
Oh, good to speak to you.
Thanks, Colin. Well, here on Slooh, we've actually got a fantastic new feature that I just want to tell you about, and that is when we're doing live shows. So that's when we have our live views from the Canary Islands, and we have those live views of the all-sky camera and also our high magnification and low magnification telescopes. If you're a Slooh member, you can actually now use something called the Slooh Star Share camera, and that's just underneath the live feed that you see on our shows. You can actually select what view that you want to see and snap a picture of it, and you can actually save a picture and take it, save it onto your computer. So as you're enjoying our live shows, you can actually take pictures and keep a record of what you've seen on the show. So do look out for that if you're a Slooh member. For now, though, we're going to be taking a short commercial break, but when we come back, I'm going to be talking to a Slooh member who's actually taken pictures and helped sort of send that data in to the scientists who have analysed it, and exactly what Colin was talking about earlier. So see you in 30 seconds. Well, welcome back to our special Comet 67P show here as part of Slooh's Comet Week, looking at these icy visitors from the outer solar system. We were talking earlier to Colin Snodgrass from the Open University about the ground observing campaign, that is, the amateurs who are helping to contribute data and images to the professional work. And it's really allowing to sort of give some incredible context to those observations that Rosetta are making very up close at the comet. And I want to bring in now somebody who's actually done this. It's Christina Feliciano from the Slooh Packer Group. Christina, thank you so much for joining us. How did you get involved with working on comets and this particular Slooh group, taking images and submitting the data?
I had always been quite intrigued by the comets. I thought that, they are the founders of our solar system. So I've always been intrigued by them. And they were one of the first objects that I would try to image when I was learning how to do coordinate images. It was really awesome to be able to watch them night for night and watching them move and watching the morphology over time. For this PACA campaign, I got involved through Padma Yadamandra Fisher, who is helping coordinate the PACA ground-based observations, and that's professional, amateur, collaborative astronomy. And we actually took part in the first PACA campaign, which was for ISON. And then we went to A1, and now we were invited back to work on 67P. So that's just sort of how we got involved with PACA, was through Padma. And it was actually, I believe, a show. We were doing shows about Comet ISON, and Padma, I believe, had seen one of the shows or saw the advertising for ISON and how you wanted to get all the information out there, and she thought that that was admirable. So now we have joined on.
That's fantastic. And just out of interest, what would a sort of normal night of collecting the data, how does it work? Do you log in and program where you need to point the telescopes and then you just get the data sent to you?
Yes, so with the 67P campaign, the Slooh engineer Paul Cox has been able to coordinate a couple missions every night on regular through the Slooh systems, and then us campaign members, us 67P campaign members, then in turn add a few more missions each night. We do a lot of collaborative work with one another. We'll discuss what we would like to image, why we would like to image it, what we think would be the best way to approach it. And we'll actually combine our missions in a pool, and we'll set coordinates, and people will actually, it's really nice to have that group setting, because everybody in the group has contributed. We have people who stack images and do formatting. Jonathan Tutton and I are the main people who do that right now. But we also have a bunch of members who donate the missions, and they're on the clubhouse with us daily, just checking up to see how the missions are going, to see if they should book something specific for a specific purpose. So we go on there each night, and we usually go a couple nights in advance, and we'll plan our missions, and then I'll just do a double check every night and make sure we have missions in line, and then the missions get delivered to us. The fits get delivered to us the next morning, and then we start working on the fits. But when we are doing the live missions, we still are able to watch the live mission interface. So it's not a big surprise when the fits comes most of the time. At least we have an idea of what we're going to see when the fits do come.
It sounds like a really friendly group. Can someone who's never even been anywhere near, say, a telescope or just had computer views in the night sky, can they get involved? Do they need any sort of knowledge or understanding of what's going on?
Okay, so I like this question because I think that it's something that a wide variety of people can partake in, especially our Slooh campaign. I have it set up so that way you don't need to know a great deal about any specific topic. Even some people who didn't know how to input the coordinates, we can offer the coordinates and say, here are the coordinates, but it's also good to learn. So some of the main things that you have to do in order to observe a comet and watch a comet night for night is set the coordinates. That's something that you could do on a planetarium software program or using Horizons, which most of us in the group use, so that we were on the exact same page. And the only thing you have to do is learn how to go through the steps. Just learn how to open the website and learn how to put in what days you want the locations for, the coordinates for. And then it generates you a list and it gives you the coordinates for the time in which you have a mission booked. So I would say that it's pretty much open door policy. I think it's a great thing with Slooh being a robotic telescope company, because when you're at home, you can sometimes have a lot more difficulty with tracking the comet, with imaging the comet. I have 3 of my own telescopes, and I don't have the funding cost to have such a good telescope, and I don't necessarily have technical expertise in order to put it together. So with
And
Slooh,
we
you
have
sort of get to negate some of that a little bit, and you get to just actually enjoy the astronomy bit of it. And I think even if you're not familiar with how to use a telescope, I believe that this is something that anybody can participate in.
And of course, I was going to say we here in the UK have clouds to deal with, so that's one thing we're up against. What sort of things have you actually seen in these images that you're collecting from Slooh? I mean, we've got a couple of them on the screen there, and it looks really interesting.
So the big thing that we've been able to watch is the morphology of the comet. And we've been able to focus on the morphology because we're imaging as much as possible. We're imaging on a nightly basis as long as weather permits. We have, I think, over 130 nights of observations, but only about 100 of those we've actually used for image submissions because wind or clouds got in the way of the images. So anyway, so we watch the morphology night for night. And when you watch it night for night, when things start changing over a week or a 2-week period, it can stand out to you because you've been watching it every day. So some things that we've been able to see in the morphology, um, we've been able to see the coma grow. We've been able to see the coma went into like a tear shape, and then it sort of grew into a tadpole shape and looked like it extended a little further to the north, maybe a month and a half ago. We've been able to watch the tail, which is really interesting because as the comet rises, you'll be able to also watch the tail. As its angle to the sun is changing, you'll be able to watch it. So in some of our first images, you'll see that the comet tail is pointing towards the bottom right, which would be the southwest. And later on, as we get now into December, you can see that the tail is now pointing in the upper right, which would be the northwest. We've also been able to watch, there's this feature in the southwest that we've been watching for months now. And when it first popped up, we weren't really sure if it was a true feature. With the resolutions that we have to be careful to make sure that we're picking out real features and we're not over processing in order to bring out something that we want to be there in our mind. So this feature developed over, I would say, about a month and a half until finally it was like, oh yeah, that's there and that's a real feature. So we've been able to watch that, and that has had brightening moments where it looks like it's brighter and denser, and it has moments where it's has almost been harder to detect. And then something else that we've been watching is the tail, and we've been trying to pin down the actual length of the tail. So those are the main things that we've been watching for, is the morphology. And we also have Bernard Luckenhoner, who does MPC submissions on 67P. So he's been keeping track of the comet's location, and we've been able to do estimated light curves at the magnitude level of the comet throughout its travels. So we could see how it's brightening, how it's dimming. Right now, it seems to be dimming a lot more rapidly over the last 2 months.
As it goes out into the outer
Yeah.
solar system. Well, Christina, thank you so much for coming on to the program and talking to us about this fascinating. It's absolutely fascinating to see these images and hear about some of the things you've been seeing. It's incredible that we could do that actually with these Slooh telescopes, and wonderful to hear the community that are really working hard to submit this data and collect it all. So thank you so much for joining us here on the show.
Thank you.
Well, we're going to take a short commercial break now, but when we come back, we're going to look at a unique way that the Rosetta team have utilized social media to really engage with people worldwide. So see you in 30 seconds.
Welcome back to Comet Week here at Slooh and our look back at the last year of the Rosetta mission. As you've already heard over the course of the show, the mission and the last year of data it has gathered from the surface of a comet has offered brand new insight into the building blocks of the universe, and it's a first for human space exploration. Another first, this is likely the first time a space agency has so successfully utilized the greatest tool available to a modern company, social media. Probably noticed I'm not Will Gator. My name is Trisha Ennis, and I am a cultural correspondent of sorts here at Slooh, bringing you everything you need to know about a variety of space-related subjects. But instead of bringing the science, I'll leave that to my more qualified compatriots, I'm here to bring a little culture to the proceedings, whether that culture is ancient, artistic, modern, or pop. Today, we're going to cross over a bit with the modern and pop culture, taking a look at the extremely engaging social media campaign put forth by the European Space Agency in the months leading up to the Philae lander touching down on 67P. Now, admittedly, it's easier to get people interested in something that is brand new, like the Philae lander, than it is to get them interested in something slightly less exciting, but instead of allowing the mission to carry its own press, they went all in on the outreach, working to engage those people who might be interested in the exciting adventure they were about to undertake, but who might be a little frightened off by the more science-heavy aspects of it. Over the course of the final months of the Rosetta flight and up to and beyond Philae's landing, the Rosetta team created several video series to engage audiences at a number of levels. They held public Google Hangouts to help answer questions about the mission, put together Ask Rosetta video clips, and created the Comet Hunters series with members of the Rosetta science team. But perhaps their most successful campaign was a series of animated clips called Once Upon a Time, which you're watching right now. Now, these humanized and anthropomorphized both Rosetta and Philae, documenting the many stages of their journey in a way that was accessible to space. It was good for fans young and old, from the scientist to the layman, everyone in between, and it really brought a lot of people together and made them really understand the mission and actually engage with these devices that really don't have a personality. Now, they even went so far as to co-produce a striking short film, which you're watching right now, starring Game of Thrones' own Aidan Gillen. The film, titled Ambition, imagines a far-flung future in which humanity has reached all new potential. Gillen's character, an Obi-Wan of sorts, explains to his protege how the ambition of the Rosetta mission allowed us to begin to understand the building blocks of the universe, and from there, harness more control over nature. It was an attempt by the European Space Agency to blend science fiction and science fact, and it's actually been nominated for a few awards. But ESA weren't the only ones spreading the word about Philae's harrowing descent to the surface of the comet. The entire thing was live blogged, or live drawn, by Randall Munroe, the creator of the popular webcomic XKCD. The humorous adventure gave a new personality and an imagination to the lander, and it was turned into a flipbook. That book and its individual drawings have been shared thousands of times on social media. With the success of the Rosetta team's social media outreach and interaction, it'll be interesting to see how it changes the face of social interaction for future missions from the European Space Agency, NASA, and beyond. Will, back to you.
Those animations, those videos, they really are very special. If you haven't seen them, go onto the ESA website, esa.int, and also follow the ESA accounts on social media, Twitter, Facebook, things like that, because they really are really heartwarming. The videos in particular I absolutely love. So fantastic to see those there, and do check those out. Well, what an incredible show. We've talked to Colin Snodgrass about the campaign to observe the comet from the ground to really get this context of 67P Churyumov-Gerasimenko. We spoke to Christina Feliciano about what Slooh members are doing and the incredible work, those pictures we've got on the screen right now, these Slooh images taken with our telescopes in the Canary Islands to see the sort of grand, wide context of Rosetta's comet. And then at the very top of the show, we spoke to Jean-Baptiste Vincent, who from the Max Planck Institute for Solar System Research, and we talked about those incredible changes that the spacecraft has seen at the comet. And well, who knows what will happen over the coming months. Surely we need to keep our eyes absolutely peeled on those images, because as the comet goes out, of course, we don't know what will happen as it goes out into the outer solar system. So the story of Rosetta, the story of 67P and Churyumov-Gerasimenko is not over yet. We've got a lot more to come, especially as Rosetta spirals in close to the comet. And of course, we will keep you up to date here on Slooh.com about everything that happens and all the updates on what's going on that incredible comet. Well, it's almost time for us to go, but I just want to tell you something about what's happening on Sunday night, because I wouldn't want you to miss our fantastic live show looking at the Geminid meteor shower. This is one not to miss. The Geminid meteor shower, arguably the best meteor shower of the year. It's just a wonderful meteor shower. Often the crisp, clear winter skies are a wonderful time to get out observing meteors. And if the skies are clear where you are, go outside, look up, and also log on to slooh.com and make sure you have us with you, because we're going to be having live commentary on the show. We're going to have live music on the show to sort of give you a sort of accompaniment to the observing. And basically, we're going to have all sorts: radio astronomy radio meteor detection to see if we can pick up the sort of transmissions or the sounds, if you like, of those meteors coming through the atmosphere when they reflect a distant radar, so radio stations. So lots to listen to and look out for on that Geminid meteor shower show. That begins at 8 p.m. Eastern time. But from us here at Slooh, we wish you a very good night and hope you've enjoyed this show. And for those of you watching on our live 24-hour channel, we'll send you back to some of the best of Slooh's past broadcasts. So good night from me, and we'll see you again next time here on Slooh.com.